Hi guys, it's Miss Cassano, and today I'm going to walk you through some of the questions from the review sheet. Feel free to skip ahead and go to the questions that you want to see. So yeah, let's get started. 1F, factor the following polynomial completely. So looking at this one, we see that we have this x squared minus 9 over here and the x squared minus 9 over here. And we're thinking to ourselves, it would be really nice if that was just some variable so we could factor out a GCF. So this is one of the ones that we do our little z substitution. So we let z equal x squared minus 9. Now, everywhere we see an x squared minus 9, we're going to substitute in for z. So it will be z cubed minus 4z. Now this is a little easier to handle. Whenever we're factoring, our first line of defense is always GCF, and my GCF here would just be z. So all my terms share a z. So I'm going to pull out my z, and that's going to leave me with z times z squared minus 4. Now, z squared is a perfect square, 4 is a perfect square, and we have a difference, so we can use dots. Z squared and 2 squared. So when we factor this with dots, we're left with, don't forget the z, you always have to bring it down, times z plus 2, z minus 2. We're not done. The question was given to us in terms of x, so that means we have to give our answer in terms of x. So now we're just going to go the other way. Everywhere we see a z, we're going to substitute back in an x squared minus 9. So I have a z right here, x squared minus 9. Everywhere I see a z, I'm going to put in x squared minus 9. Minus 9 plus 2, x squared minus 9 minus 2. Now the question says to factor completely, and that means that if we have anything else that we can factor, we have to do it. We have to get it down into a form that's fully factored. We can't leave anything factorable. So here I see that I have x squared, which is a perfect square. I have 9, which is a perfect square. And I have a difference, so that means I can use dots again. So x squared minus 9 factored using dots is x minus 3, x plus 3. X squared minus 9 plus 2, well that just simplifies to x squared minus 7. X squared minus 9 minus 2 simplifies to x squared minus 11. That is fully factored, and we are done. 2C, write the following polynomial as a product. So this is basically saying take this polynomial and break it down into a number of products. In more simple ways, in more simple terms, that just means to factor it. Now, our first line of defense when we factor is always to look for a GCF. And looking at this polynomial, I don't see a term or a variable or a number that all of these terms share or both or all have. So that means our problem doesn't have a GCF. Thinking back to that factor flowchart I gave you, the next step in our flowchart is to count how many terms we have. And this polynomial has 1, 2, 3 terms. And our strategy for factoring a trinomial or a polynomial with 3 terms is to use the AC method. So that means you're going to take the first term and multiply it by the last term. When you do that, you get 168 x squared y squared. Now this was one of the questions in class I had you correct. That should be 14y squared, not 14x squared. And what our job is right now is to find two numbers that multiply to 168 x squared y squared and two numbers that add to negative 29xy. So if you want, you could pause the video right now and try to come up with those two magic numbers. So the two magic numbers are negative 21xy and negative 8xy. and you're going to take those two numbers and substitute them in for negative 29xy. You're not changing the value of your polynomial. All you're doing is just writing negative 29xy as an addition problem. So now your next step here is to split it down the middle and factor it. At this step, every single time you're going to be factoring by GCFs. You're going to be looking for terms and variables that these groups of numbers share. So in the first one, we can pull out, or they all share, a 4x. So that leaves us with 3x minus 2y. Now, whatever you get in the parentheses over here has to match the parentheses you get over here. So in order to do that, we have to pull out a negative 7y. And that would leave us with 3x minus 2y. These match, so you know you did them right. Now, all you're going to do is just lump it together. 4x minus 7y times 3x minus 2y. If you were to multiply out these two binomials, you would end up right back at the beginning polynomial. 3b, factor the following polynomial completely. Now, going back to our factor flowchart, our first step is to pull out a GCF. There's no variable that all these terms share, and there's no number that all these terms share, so our problem doesn't have a GCF. Moving on, our next step is to count the terms, so let's do that. 1, 2, 3, 4, 5, 6. So we have a 6-term polynomial. Now, on our factor flowchart, the way that we handle these is to factor by grouping. We can't just split it right down the middle, 3 and 3. We have to look at our exponents. So remember in class we said when it's decreasing, increasing, we draw the line where it starts to increase again. 3 to 1 is decreasing, 1 to 2 is increasing, so we draw the line where it's increasing. This is only for polynomials that have more than 4 terms. If we had a polynomial with 4 terms, we would karate chop it right down the middle. But since this has 6 terms, we have to look at the exponents, and whenever it goes from decreasing, back up to increasing, so 4, 2, back up to 3, we draw the line right where it starts increasing again. And then we're just going to factor these by GCF. So we grouped our terms together in a way that we can factor them by GCF. That's why it's called factoring by grouping. So in our first grouping, we can pull out an x squared. So we're left with x squared minus 4. Same rule applies. Whatever you get in the parentheses over here, you should get in the parentheses for the other two groups. Over here, we have a GCF of 4x. So we're left with x squared minus 4. It matches, so we're good. And our last one, we can pull out a negative 12, and we're left with x squared minus 4. It matches, so you know we're good. We are going to lump these front terms together to give us a polynomial that is x squared plus 4x minus 12, and that's times our x squared minus 4. Now it says factor completely, and we are not done. X squared is a perfect square, so we can break that up, and 4 is a perfect square, so we can break that up using dots. So that factor is x plus 2, x minus 2. Over here, x squared plus 4x minus 12, that's a trinomial, so we are going to factor that using the AC method. We're going to take our first term and multiply it by our last term. I'm just going to write it over here because that's where there's room. That gives us negative 12x squared. So we want to find the two numbers that multiply to negative 12x squared and add to 4. You can pause the video and try to figure out those two numbers. So those two magic numbers that multiply to negative 12x squared and add to positive 4 are positive 6x plus negative 2x, or positive 6x times negative 2x. We take those two magic numbers and we substitute them right into the middle of our equation. We're not changing anything because 6x plus negative 2x is 4x. So we're just writing it in a different way. All right, we are going to split it down the middle and factor by grouping again. So we pull out our GCF. Our GCF here is x. This leaves us with x plus 6. And over here, our GCF is negative 2, x plus 6. X plus 6 matches with x plus 6, so you know you did it right. And you just smush the front two terms together. Rewrite your parentheses ones, and that's it. Now, our answer to this question is x minus 2, x plus 6, because that's this trinomial factored completely, times, don't forget this one, x plus 2, x minus 2. If you were to multiply all four of these binomials together, you would end up at our original polynomial. Now, there is another way that you can write this, and if it was a multiple choice question, it could be represented either in the way I just wrote it or in this way. We have two factors of x minus 2, so you could write that as x minus 2 squared times x plus 6, x plus 2. For D, factor the following polynomial completely. Now, again, we always start by looking for the GCF. I don't see one here, so we move on. This is a binomial, and in order to factor a binomial, which is just a polynomial with 1, 2 terms, you could either use a difference of two squares or perfect cube. Now, right off the bat, we know we can't use a difference of two squares because we have a plus sign here. And in order to use a difference of two squares, we need to have a minus sign. So that gives it away that we're probably going to be using the perfect cube one. So our first step when using a perfect cube is to uncube our cubes. So we have x cubed, so I'm going to take the cubed root of x cubed in order to uncube it. Well, the cubed root of x cubed is just x, and this is our a term. The cubed root of 64y to the 6th, well, the cubed root of 64 is just 4, and the cubed root of y to the 6th is just 2, y squared. So that is our b term. All exponents that are multiples of 3 are perfect cubes. So now all we do is just put this into our long equation. So it's, I'm just going to rewrite it here, a cubed plus b cubed equals ab times a squared, ab, b squared. And there's a reason why I left out all the signs. We learned a little mnemonic device called SOAP, and that helps us figure out what our signs are. So it's same, opposite, always positive. So depending on our original question happens to be a addition one, but if it was a difference one, the signs would be different. But depending on the sign of the original polynomial, that's going to determine your signs in the factored version. So same, that means it would be the same here, so it would be a plus b. Opposite would be a squared minus ab, and then always positive. The last term is always positive. So all we're going to do is take our a term and our b term and just plug it into this. So a is x, so x plus 4 times x squared minus 4xy squared plus 4y squared all squared. I wrote it like that because a lot of the times we all make the same mistake when we're doing this question, and we think that 4y squared is 4y to the 4th, but you have to distribute your square. You're squaring the 4 and you're squaring the variable. So it's actually 16y to the 4th. And that's it. That is factored completely. 7a, what values of x make the rational expression undefined? Whenever you see the word undefined, you know that that means your bottom has to be equal to 0. Undefined means the fraction has a denominator of 0, which is not good. So what this question is asking you to do is find the values of x that makes it 0. So all you're going to do is just take the bottom of your rational expression and just set it equal to 0 and solve for x, because those values of x will make it 0. So x squared minus 2x minus 15 equals 0. This is a trinomial, so I'm going to use my AC method. Negative 15x squared. I'm going to find two numbers that multiply to negative 15x squared and add to negative 2. Those two numbers are negative 5x and 3x. Substitute them back in. X squared minus 5x plus 3x minus 15 equals 0. Split it down the middle. Right now, you're always factoring by GCF, so I'm going to pull out a GCF of x, which leaves me with x minus 5. I'm going to pull out a GCF of 3 for this grouping, which leaves me with x minus 5. My parentheses match, so that means I did it right. So I'm left with x plus 3, x minus 5 equals 0. Now I'm going to set both of these factors equal to 0 and solve for my values of x that make the bottom of my function undefined or equal to 0. Minus 3 to both sides. X equals negative 3 plus 5 to both sides. X equals 5. So the values that make my rational expression undefined, or it makes the bottom equal to 0, are x equals negative 3 and x equals 5. So if you substituted in x equals negative 3 and x equals 5, you would get a denominator equal to 0. 8f, simplify completely. So this is a rational expression, and all they're asking us to do is simplify. There's no equation to solve. We're not solving for x. We're just trying to simplify it. And these behave just like normal fractions that we've been dealing with since elementary school. We want to follow our two steps. Our first step, always with dealing with rational expressions and equations, is to factor first. Fa-fa, factor first or fail. So I'm going to factor my numerator, x third minus 64. X cubed, 64. This cube right here is telling me that we're probably going to use sum and difference of two perfect cubes. So I'm going to uncube my cubed. The cubed root of x cubed is just x. This is my a term. Cubed root of 64 is just 4, and that's my b term. So we got x minus 4 times x squared plus 4x plus 16. This is our numerator. And then I'm going to factor my denominator. 16 minus x squared. Well, we know 16 is a perfect square. We have an x squared, and we have a difference, so that is telling us to use difference of two squares. 16, the square root of 16 is 4, and the square root of x squared is just x. So this factored is 4 minus x times 4 plus x. And this is our denominator. I'm just going to rewrite my rational expression with my factored forms. So my numerator is now x minus 4 times x squared plus 4x plus 16. And my denominator is now 4 minus x, 4 plus x. My next step would be to cross out common terms. And right now I don't really see one. But what I do see is 4 minus x and x minus 4. And that's one of our special properties. If you remember, we learned in class that a minus b over b minus a, so basically when it's just flipped, is equal to negative 1. So that means we can cross out x minus 4 and 4 minus x, and we'd be left with a factor of negative 1. That's really all we can do with this. So we're just going to rewrite it with our negative in front. So negative x squared plus 4x plus 16 all over 4 plus x. And that's our answer. Nine C, perform the indicated operation. So we have x over 4 minus x divided by 2x over x squared minus 16. We're just simplifying here. There's no solving for x. There's no equal sign. This is not an equation. It's just an expression. So our first step always when dealing with these is to factor first. Now the only thing I can see I can factor is x squared minus 16. X squared is a perfect square. 16 is a perfect square, and we have a difference, so I'm going to use dots. X minus 4 times x plus 4. I'm just going to rewrite my expression now with my in my factored form. X over 4 minus x divided by 2x over x squared minus 16. Now, this is a division problem, and we have an extra step when dealing with dividing fractions. Again, rational expressions and simplifying them behave just like regular fractions. Whenever we're dividing two fractions, we have to do keep, change, flip. Now that's only for division. If we were multiplying these together, if it was x over 4 minus x times 2x over x squared minus 16, we wouldn't have to do this extra step. But since we're dividing, we have to do a keep, change, flip. So I keep my first rational expression in place. I change my operation to multiplication, and I flip my second fraction. So whatever is on the bottom, so my x minus 4 times x plus 4, is going to be on the top, and whatever's on the top is going to be on the bottom. So after we perform our keep, change, flip, we are ready to start crossing out any common terms. Right now, I see I have an x on the bottom and an x on the top, so I'm going to cross those out. And I see again that I have this 4 minus x, x minus 1, and we learned that that special property, a minus b over b minus a, gives us a factor of negative 1, so we can cross these two out and be left with a negative 1. And that's all the simplifying I can do, so I am left with x plus 4 over 2, with my little negative sign in the front. (10b), perform the indicated operation. So we have 6 over y minus 5 minus y plus 5 over y squared minus 25. As always, when we're dealing with rational equations and expressions, our first step is to factor first. So I did this ahead of time. I saw that the only thing I could factor is that y squared minus 25. It's a dot, so that means it breaks up into y plus 5, y minus 5. All I did down here was just rewrite my expression with in my factored form, which it turns into 6 over y minus 5 minus y plus 5 over y plus 5, y minus 5. Now, at this point, our next step would be to find my least common denominator. However, if you see another way or an easier way to do it, by all means, you can do it this easier way. When we factor, we have a y plus 5 up here and a y plus 5 down here. So you could very easily just cancel these out. It's totally allowed. And you'd be left with 1 over y minus 5, which would give you an answer of 5 over y minus 5. You could do it like that. You could skip all the LCD and building up and stuff. However, I'm going to show you all the steps just because. But if you saw that, you are more than welcome to use that method. All right, so we factored, and we're going to use our factors and our denominators to find our least common denominator, because our goal here is to be able to get two fractions that have the same denominators so I can combine my numerators. So in class, I told you to start over here and write down the first factor. Well, our first factor is y minus 5. Keep going until you hit the next fraction, and our factors on the bottom are y plus 5, y minus 5. I already have a factor of y minus 5 in my LCD, so I'm not going to include this y minus 5. However, I'm going to include the y plus 5. So our least common denominator is y minus 5, y plus 5. Our next step is to build up each fraction to have our least common denominator, and all that means is we're going to multiply by what's missing. So 6 over y minus 5, well, we're missing our y plus 5. So I'm going to multiply by y plus 5 over y plus 5 times 6 over y minus 5 minus y plus 5 over y plus 5 over y minus 5. Well, that's not missing anything, so I don't need to multiply by anything. It already has my least common denominator. Now we have two fractions that have the same denominator, so that means we are ready to start combining our numerators. Again, we are not solving for y here, so we wouldn't do the thing where we throw out our denominators. We only do that when we're solving for a variable. But since we're just simplifying, we're going to keep our denominators. You can think about it like subtracting and adding normal fractions that we've been doing since elementary school. So I'm going to combine my numerators, but first I'm just going to distribute my 6 to my y and my 6 to my 5, which gives me 6y plus 30. And then I'm going to distribute my negative sign to my y minus 5 all over my denominator of y plus 5, y minus 5. I'm just going to combine my like terms. I have 6y and negative y. That gives me 5y. I have 30 minus 5, which gives me a positive 25 over y plus 5, y minus 5. So we're almost done. We're almost totally simplified, but we can simplify this just a little bit more. I'm going to pull out a GCF in the numerator of 5, which would leave me with y plus 5 over y plus 5, y minus 5. Well, we have a common term of y plus 5, so I'm going to cross those out, and I am left with 5 over y minus 5. And that is totally simplified. 11a is to algebraically prove that 1 plus 1 over x cubed plus 8 equals x cubed plus 9 over x cubed plus 8. Now, proving something is different than solving. So in this, we're not solving for x. We're only going to be working with one side of the equation, and we're going to try to make it look like the other side. So in class, I told you pick one side to lock up. Usually you want to lock up the one where there's not much you can really do to, like x cubed plus 9 over x cubed plus 8. There's really not much you can do. So that means we're only going to be touching 1 plus x cubed plus 1 plus 1 over x cubed plus 8. Now, I would like to get a common denominator and see if I can combine these two fractions in any way to give me x cubed plus 9 over x cubed plus 8. So my common denominator is going to be x cubed plus 8. So my LCD, x cubed plus 8. You could figure that out just by looking at it, or you could do the trick that I showed you in class. Start with this fraction, 1 over 1. My factor would just be 1, so I move on. And then my other factor would be x cubed plus 8, and that's how I got my LCD. So now I'm going to multiply everything. I'm going to multiply and build up my left side of my equation. So 1 over 1 is missing x cubed plus 8, so I'm going to multiply by x cubed plus 8. Times 1 over 1 plus 1 over x cubed plus 8, that's not missing anything, so I don't need to multiply by anything, plus 8 equals, and I'm trying to show that this side of my equation equals this side, so I'm not touching this side. I locked it up. We can't touch it. So 1 times x cubed plus 8 is just x cubed plus 8 over x cubed plus 8 plus 1 over x cubed plus 8 equals x cubed plus 9 over x cubed plus 8. Now, since we have common denominators, we can combine our numerators. So, x cubed plus 8 plus 1 over x cubed plus 8 equals x cubed plus 9 over x cubed plus 8. And we get x cubed plus 9 over x cubed plus 8 equals x cubed plus 9 over x cubed plus 8, which is what we wanted to happen. 12C, solve for x, write your solutions as a set, check for extraneous roots. So now we're solving a rational equation, and our goal here is to find a common denominator so that we could get all the fractions over the same thing, and then we can throw out our denominator and make it a little easier to solve. So our first step always is to factor first, and I saw that I could factor the denominator, so I used my AC method to factor x squared minus x minus 12, and I got factors of x plus 3 and x minus 4, and then I just rewrote my equation using my new factors. So now my next step is to find an LCD. But I'm having a little bit of a problem. I have so far that my LCD is probably going to include x plus 3. So, because I have a factor of x plus 3 here. I keep going and I keep going and I hit 4 minus x. But 4 minus x and x minus 4 are the same things. So before I can declare an LCD, I have to make 4 minus x look like x minus 4. So let's do that. 2 over x plus 3. We know that 4 minus x is equal to negative 1x minus 4. So I'm just going to bring that negative up to the top and rewrite 4 minus x as x minus 4 equals 2x minus 2 over x plus 3, x minus 4. The reason why we can just pull out that negative 1 is because we can think about it as pulling out a GCF. So we have 4 minus x. I want to pull out a GCF of negative 1. Well, GCF just means you're dividing each term. So negative 1 times 4 divided by negative 1 is negative 4. Negative x divided by negative 1 is positive x. And you can rewrite that as negative 1 times x minus 4. So that's why we can do it. All right. So looking at this, our LCD is going to be, well, I have a factor of x plus 3, so I'm going to write that down. And then I have a factor of x minus 4, so I'm going to write that down. And then I repeat x plus 3 and x minus 4 again, and we don't write repeating, so that means we're done. Our LCD is x plus 3, x minus 4. So I want to build up each fraction to have our least common denominator because I want to get to a point where I can throw out my denominators. So you're going to multiply by what's missing. So 2 over x plus 3 is missing my factor of x minus 4, so I multiply that by x minus 4 over x minus 4. Negative 3 over x minus 4 is missing my factor of x plus 3, so I multiply that by x plus 3 over x plus 3. And 2x minus 2 over x plus 3 times x minus 4 isn't missing any of my factors. It already has my least common denominator, so I don't need to multiply that by anything. Now we are going to just rewrite it neater. So 2 times x minus 4 times x plus 3 minus negative 3 times x plus 3 over x minus 4 x plus 3 equals 2x minus 2 over x plus 3 x minus 4. All right, so clearly all of our fractions have the same denominator, so we can just toss them. We don't need to think about them anymore, for right now at least. The reason that we can do this is because of the cross multiplication I showed you in class. If we were to combine these two fractions because they have the same denominator and then cross multiply both sides, the denominators would cancel out anyway. So this is just saving you a step. So just throw out our denominators, and at the same time I'm just going to distribute what I need to distribute. So I just threw out my denominators and I distributed my 2 to my x and my 2 to my 4, my negative 4, and then I distributed my 3 to my x and my 3 to my 3. So that gives me 2x minus 8 plus 3x plus 9 equals 2x minus 2. And this is pretty much a regular equation that you've been solving since middle school. I'm going to combine like terms, so I have 2x and 3x. Combining them would give me 5x, negative 8 and 9. That would give me 1 equals 2x minus 2. I'm going to subtract 2x and get it over to this side. So 5x minus 2x is just 3x plus 1 equals negative 2. Subtract 1, and you get 3x equals negative 3. Divide both sides by 3, and you get x equals negative 1. So the solution to this equation is x equals negative 1. Now, our last step is to check. And what we're checking for is something called extraneous roots. And an extraneous root is a solution that you get to the rational equation. However, when you plug it back in to the original, you get an undefined fraction. So it's kind of like a solution, but it's a fake solution. It's not real. So let's go back up and check and see if negative 1 would make our denominator 0. So x plus 3, if I plugged in a negative 1, I wouldn't get 0, so we're good. 4 minus x, if I plugged in a negative 1, I wouldn't get 0, so we're good. X squared minus x minus 12. I'm just going to look at the factored form of it, because x plus 3 times x minus 4 is the same thing as that, but it's just easier to see if I'd get 0. So if I plugged in a negative 1 to this, I wouldn't get 0. So negative 1 is a solution. We don't have any extraneous roots, and we don't need to reject anything. It takes Farzana 2 hours to clean the garage. It takes Alan 3 hours to clean the same garage. If they work together, how long will it take them to complete the job? So this is one of those work rate problems that we looked at in class. And they get set up the same way pretty much every single time. So we have one garage for how long it takes Farzana to clean it, one garage for how long it takes Alan to clean it, equals one garage for them to work together. So I just did my let statements. I let F equal the number of hours Farzana worked, A equal the number of hours Alan worked, and then T equals the number of hours they worked together. Now, if they were cleaning 2 garages, the only thing that would change is this number up here would just be 2. So that's just something to look out for. But you pretty much set them up the same way every single time. So F equals the number of hours Farzana worked, so it would be 1 over 2 plus the number of hours Alan worked would be 3 equals how long it would take them to clean the garage together, which is what we're looking for, which is x. So this is a pretty basic rational equation. We are going to try to find an LCD and then solve it. So in this one, my LCD would be 2 times 3 times x. So all I did was just go from fraction to fraction and see what my factors are. So my LCD is 6x. I want to build up each fraction so that they all have the same denominator of 6x. So I'm just going to multiply by what's missing. 1 over 2 is missing a factor of 3 and the x, so I'm going to multiply by 3x in order to get it to be 6x, so 1 over 2, plus 1 over 3 is missing the 2 and the x, 1 over 3, and 1 over x is missing the factor of 6, so I multiply it by 6 over 6. So 3x times 1 is just 3x over 6x, plus 2x times 1 is just 2x over 6x, and 6 times 1 is just 6 over x, 6x. So we have the denominators all the same, so that means we can just throw them out. So that leaves us with 3x plus 2x equals 6. 3x plus 2x is 5x equals 6. Divide both sides by 5, and you get x equals 1.2 hours. So it would take them 1.2 hours to clean the garage together. Suppose you are taking the SATs. You have answered 50 questions and have gotten 35 correct. How many correct questions will you have to answer in a row to have an overall score of 75% correct? So this is one of those success rate problems that we looked at. And these two get set up the same way every single time. You have some ratio of success already established, and basically the question's just asking you how to get from that ratio of success to your desired ratio of success, or your desired percentage of success. So they get set up the same way each time. You do your original success ratio, which was 35 over 50, plus x over x, and we let x equal the number of questions needed to get right, equals our desired success ratio, which in this case is 75 over 100. Now this x over x, we're trying to figure out how many questions we need to get right in order to get a 75%. But for every question that we get right, we have to add it to also our total questions answered, because, well, if you get a question right, that means you answered the question. So, yeah. And then at this point, we would just cross multiply. So we would do 100 times 35 plus x and 75 times 50 plus x. So when you cross multiply, you distribute the 100 to the 35 and the 100 to the x, and then the 75 to the 50 and the 75 to the x. So you get 3,500 plus 100x equals 3,750 plus 75x. And then we're just going to solve for x from here. So I subtract 35 to both sides. You're left with 100x equals 250 plus 75x, subtract 75x to both sides. And you're left with 25x equals 250. Divide by 25, divide by 25, and you get x equals 10. So you would have to answer 10 more questions correct in a row to get a success rate of 75%.